Hello and welcome to KISS Chemistry. This stands for Keep It Simple Student, brought to you by Ms. Kissinger. I hope you find my tutorials helpful and useful, and thank you for watching. This reaction. In this case, we are going to use sodium and chlorine as our example. In this case, sodium is a metal, so we would count that as a solid, and chlorine is a gas. And since it is a gas, it needs to be diatomic, which means we need two. So chlorine is always bound with another chlorine. And we want to decide what this will become. So we know with synthesis, we're going to have two items becoming just one. In this case, we are going to produce sodium chloride. In order to do this, we have to think of the charges of each of these compounds because we have a metal and a non-metal. In this case, sodium will take on a +1 charge when it becomes an ion, and chlorine will become a -1 when it becomes an ion. So our product in this case is going to be NaCl, also known as table salt. When we look at this, you might notice that we don't have the same number of elements on each side. Here we have 1 chlorine and 1 sodium, but in our reactants, we have 1 sodium and 2 chlorine. So we need to consider conservation of matter. That means that we cannot create or destroy things. So in this case, we have 2 chlorines in the reactants and 1 chlorine in the product. In order to balance this, the only thing we can change are the coefficients, or the numbers that come out in front, which we will call them moles. So in order for sodium and chlorine to react, we have to change the number of moles to get sodium chloride. So in this case, since we have 2 chlorine, we need to have 2 chlorine in the products. So what we can do is we can add a 2 in front. Now we have 2 chlorines and 2 sodiums in our products. But notice in our reactant, we still have just 1 sodium. So we have to change the number here also. So in this case, we're going to put a 2 in front. This means now we have 2 sodium and we have 2 chlorine. So we can make that just 1 chlorine gas will produce 2 sodium chlorides. So again, notice in this reaction, we have 2 different reactants coming together to form 1. Okay, our second example, we notice here we have magnesium, which is a metal, and nitrogen, which is a gas. So we could say this is a solid and this is a gas. We want to determine what the product will become. So again, since we have a metal and a non-metal, we have to be forming an ionic compound. So we know we're going to have Mg and N, but we need to figure out what's going to make this compound neutral. So looking at both of these elements, I'm going to determine the charges looking at the periodic table. Magnesium will always take on a +2 charge, whereas nitrogen will always take on a -3. In order for us to have a neutral compound, we have to figure out what number do they have in common. So for both of them, 2 and 3 both have a common number of 6. Now, if we look at this, 3 times 2 is going to give me a -6. And when I look over here, I got to figure out how many magnesiums I would need. So I need to have a +6 when I bring it down over here. So we're not going to change these subscripts here, but we're going to change them here on the final product. So that means that I need to have 3 magnesiums for every 2 nitrogens. Now, as I mentioned before, we need to go back and we need to make sure that we balance the equation. So we can only change the number of moles, which is the number in front. In this case, for magnesium, I have 3 magnesiums and I only have 1 magnesium. So I'm going to put a 3 here in front. This now means that I have 3 magnesiums. Over here, I have 2 nitrogens and I have 2 nitrogens. So I only need 1 here. And already we can look at the top part here and we see that I only need a 1 here. So again, in order to determine the product, I need to determine the charges of the nonmetal and the metal first to determine the product. After I've created the equation, I can go back and change the number of moles of each product in the beginning. All right, decomposition. This is exactly the opposite of what synthesis is. So if I looked at sodium chloride, I don't have to worry about balancing the charges on sodium chloride. In this case, we have 1 and 1. That's because sodium has a +1 charge and chlorine has a -1. So they already cancel each other out. When they break apart, I need 2 products. So I'm going to need to consider what they'll break down into. So in this case, I am going to have sodium as one product, and I'm going to have chlorine. Now I need to consider, are either of these diatomic? So sodium, with it being a metal, is not diatomic. And chlorine is one of our diatomic 7. When it's a gas, we need to make sure to put a 2. Now again, just like before, we need to go back and balance the equation. So when I look at these, I have 2 chlorine down here, and I need 2 chlorine up here. The only thing I can change is this number here. So I'm going to put a 2 here. That means I have 2 sodium chlorides. And over here, that means that I have 2 sodium and 2 chlorine. So now my chlorines match, but what doesn't match is my sodium. I only have 1 sodium here. So by putting a 2 in front of here at the mole number, then that means now I have 2 sodium and I already have 2 chlorine. So now this is a balanced reaction.